Hello, my name is Leo Seaman and I'm a Senior Research Fellow of Educational Technology at the University of Tartu in Estonia. And I would like to present the work we've been doing entitled Developing Smart Device-Friendly Asymmetric Simulations for Teaching Collaborative Scientific Inquiry. Let me start with some background. Two important characteristics of successful collaboration are equal participation and diversity of perspectives. These features help to establish the condition that's been called positive interdependence. Johnson & Johnson introduced this term positive interdependence and defined it as follows. It is the perception that we are linked with others in a way so that we cannot succeed unless they do. Collaboration is a vital part of the scientific practice. That most scientific publications involve co-authors, and solving complex scientific problems requires distributed reasoning. The research question that eventually we would want to answer is that we have a target group of 11 to 15-year-olds, and the question we would like to answer is that how to best design collaborative activities so that they promote the development of both collaboration and scientific inquiry skills. The solution is going to involve in some way computer simulations. What's been done in the past involving computer simulations on the collaboration side is that the Assessment and Teaching of 21st Century Skills project has used computer simulations to assess collaboration skills. And they've done it using so-called asymmetric simulations. We'll come back to this because we're going to have a demo where I show you what an asymmetric simulation looks like. We envision, as the title kind of said, smart device-friendly collaborative activity. And so in this case, students are going to be speaking like face-to-face. And so they don't get, in terms of typing in messages, this kind of delay. But they have immediate face-to-face communication. However, that their devices should be kind of hidden from each other because we want them to kind of use asymmetric simulations, but without showing each other what's on the simulation, but just discussing in words. And the other thing, just as a reminder, is that in general, science education has benefited a lot from computer simulations because they promote the inquiry-based learning approach. Inquiry where students can kind of test different variables and see what are the cause and effect relationships. Let's do a demo, then you can see what we've done in terms of developing an asymmetric collaborative simulation. And we're going to be using the GoLab platform. This is available at golabs.eu. It's kind of a free platform for any internet user who wants to create kind of a learning space and integrate different elements of multimedia. And in this case, I'm going to open up two of these links here, the Seesaw task version A and Seesaw task version B. When I open up this link, I have to enter in some username, and then when I open it, this kind of screen appears. In my smartphone here, if I log in and open up the other link, the version B link, then in terms of the beginning text description of the assignment or the task, these will be the same in both versions. And just to quickly read some key points is that, dear student, goal of this task is for you to collaborate together with a partner and solve a problem about balancing a seesaw. The task has two parts, a simulation of a seesaw that both you and your partner partially control, and a question for you to answer. The question is located here at the bottom. And so for version A, the question reads, is it possible to balance the seesaw using a total of 3 objects on the seesaw? If so, then describe exactly how in the space below. In version B, if I scroll down to the question, then it's slightly different. It reads as follows. Is it possible to balance the seesaw using a total of 2 objects on the seesaw? And so notice that this is something that the students should arrive at when they're discussing this problem, that they have different goals, and this is something in terms of collaboration that should be established from the beginning. But then going back, let's kind of open up this simulation. The instructor has to distribute different numbers to pairs of students. And so maybe I put in just a random number, 5, 6, 7, 8. because what matters is that the two students who are collaborating open up these simulations that have the same room number. In this way, in terms of the technology, that the simulations are synced to one another. So that for example, if I place an object here on the seesaw, the effect is seen in both screens. But notice that the asymmetry means that the person here in version A can only place objects on the left side of the seesaw. If they try to place objects on the right side, then the simulation doesn't allow for it. And also notice that in version B, the student doesn't have any objects to begin with. And so this is something that they have to discuss, that there is this kind of box here where one can share an object between each other. And then it becomes kind of just a trial and error that they start to see, okay, what kind of options do I have that I could possibly balance the seesaw using the different amounts of objects on the seesaw. So let me now come back to the presentation. So we just saw an example of the Seesaw asymmetric simulation. If you can look at our paper on page 2, you'll also see that we've developed a total of 4 different asymmetric simulations. They cover topics such as balancing the seesaw, rate of photosynthesis, inheritance of traits, and electrical circuits. And each of these different simulations kind of has a task involved with it that evokes positive interdependence, meaning that no single student could solve the task by themselves, that they require the collaboration and dependence of the other student to successfully complete the task. So in conclusion, we believe that asymmetric simulations offer promising ways to support the development of both inquiry and collaboration skills of students, but open questions do remain, such as to what extent is positive interdependence really felt by students during the solving of tasks involving asymmetric simulations? How should science teachers provide support during student engagement with such simulations? And in general, how do collaboration skills in young people develop? Finally, I would like to acknowledge that this study was supported by the Estonian Research Council, and thank you very much for your attention.